negative 2. I plug in pi over 3, cotangent pi over 3 minus cotangent pi over 6. I always tell my students don't bother with cotangent because cotangent is cosine over sine. So for pi over 3, cosine pi over 3, this is the square root of, I'm sorry, it's 1/2. And this is the square root of 3 over 2. And this is reversed. So negative 2, 1/2 over the square root of 3. It's flipped. So this is the square root of 3 over 3 minus this over this is the square root of 3. You can distribute or switch, whatever. So 2, the square root of 3 minus the square root of 3 over 3. I was thinking for a second that cosecant without a power. We have formulas for that, but that's for, I can't show that because we haven't discussed that yet. It's not part of Calc 1. But this is a straightforward situation. Cotangent prime is negative cosecant. So the fact that I have to use a negative is clear. So negative cosecant squared times negative 1 is cosecant squared. So cotangent pi over 3 minus cotangent pi over 6. Cotangent is cosine over sine. For pi over 3, this is 1/2 and this is square root of 3 over 2, and I flip. And I get this. For pi over 3 is this over this. So when I flip, I get the square root of 3. And I didn't want to have a negative in front, but it doesn't matter really. I distributed in here. So 2 outside, the square root of 3 minus square root of 3 over 3. So this is it. You can enter it. Now, another option will be this. 1 minus 1/3, which is 2/3. So we can also write it as 4 the square root of 3 over 3, because these are like terms. 1 minus 1/3 is 2/3. So you either enter it like this or simplified, fully simplified. Both should be accepted. Either 4 the square root of 3 over 3 or this.
All right, yep, that worked.
Yeah, so there is no need to go through these steps because we already have a direct antiderivative. Good. Anything else? Do we want to look at another example like this one or not?
We could probably look at the third one or not, or 5.3. I'll try and find the question.
For the derivative, a function given in the form of a derivative of a integral?
Yeah.
Okay, so let's look at one more so we can move on to the next topic.
Oh, what about 16? I don't know if your 16, Aaron, looks like mine.
Yeah, 16. That's function.
Ready?
Yeah. So it's f of x. Well, it's capital F of x. I don't know if that matters.
It doesn't, but I have to use what you're giving.
Sorry, and it says find the derivative. So it's from x to x squared, and then it's e to the power of t to the power of 4 dt.
Perfect. Good. So this one needs a lot of preparation.
Yeah.
Remember, fundamental theorem of calculus part 1 requires the lower limit to be a number, any number. And we do have properties of definite integrals that allow us to split the integral from x to whatever plus from whatever to x squared. From e to t to the 4th dt, e to t to the 4th dt. This is ready for differentiation, but this one is not. We used it a minute ago. I have to flip. Oh. Good. So now we can differentiate. Luckily for x, I don't have to differentiate because x prime is 1. So I have negative e to x to the fourth plus. Here, when I replace t by x squared, I have to take it to the fourth power, so e to x to the eighth, but times the inner function prime, which is 2x. I will rewrite it with 2x in front, but nothing else can be done. And this is it. So I would like us to review now the Riemann sum and an approximation with 4 subintervals. Did you enter this? Is it okay moving on?
Yeah, that's good.
Okay, moving on. Would you like to choose a function and an interval?
Hold on, I'm sorry. Mine's not good. Aaron, can you read me how you entered it? Because it's not taking it from me.
I did 2x e to the power of x to the power of 8 minus e to the power of x to the power of 4.
Oh, I forgot the x in the power.
Yeah,
as well.
it's x.
And then to the power of 4.
Yeah.
Got it. Thank you.
So we want to illustrate the Riemann sum. Okay, so we're working on this. Here's a simple function, f of x, 4 x to the third plus 2x. And the interval is 0, 2. We have 3 preps. What is the first prep?
Name the function.
Delta x. 2 minus 0 over n. Prep number 2 is xi. 0 plus delta x times I. 0 plus delta x times I. So this is 2I over n. Last prep is f of xi. 4. This to the third power. 8 I to the third over n to the third plus 2 times this. 4I over n. Finally, the area. And you should also determine it from 0 to 2. 4x cubed plus 2x dx. You should always do this. It will ask you to find it first. So you know what to expect. X to the fourth over 4 plus 2x squared over 2 from 0 to 2. I plug in 2, 16 plus 4. The answer should be 20. Now the area is the limit as n approaches infinity from the sum from I equals 1 through n from delta x 2 over n multiplied by f of xi. 32 I cubed over n cubed plus 4I over n. Any questions so far?
No.
I take 2 over n outside. I apply the sum to this, taking the constant outside. 32 over n cubed, the sum of I cubed. I apply the sum to this, 4 over n, the sum of I. I replace this, and I replace this. This by n squared plus 2n plus 1 over 4, and this one by n plus 1 over 2. Please have those formulas with you. Then limit as n approaches infinity, 2 over n, 32 over n cubed, n squared plus 2n plus 1 over 4 plus 4 over n times n plus 1 over 2. I'll simplify. Don't simplify here because you still have to have n. Limit n approaches infinity, 2 over n. The least common denominator is n. I distribute. And I distribute 2n squared plus 2n. Limit n approaches infinity. The denominator now becomes n squared. 8 plus 2 is 10. 10 times 2, 20n squared. 16 plus 2 is 18 times 2, 56n plus 16. After L'Hopital's rule, 20. Now, what if I'm asked to approximate? So let's say I have the integral from 0 to 4 from e to x squared dx. We cannot even try to find the antiderivative of this. So we're asked to approximate using 4 subintervals. And I can let you choose leftmost point, rightmost point, or midpoint. Which one do you prefer? Left, right, mid.
Midpoint.
Midpoint. It's the best. I agree. Zero to 4. 1, 2, 3. Midpoint, 0.5. Midpoint, 1.5. Midpoint, 2.5. Midpoint, 3.5. So therefore, approximately, I should write, base times height. But the base is 1. I'll skip that. F of 0.5, f of 1.5, f of 2.5, f of 3.5. Where f of x, of course, is e to x squared. And you know how I like to do this. And I have a video already posted for you. Go to Stats, Edit, Clear. Point 0.5, 1.5, 2.5, 3.5. And now E, and the power would be list L1 squared. Enter. Wow. 208,981. Okay. So then get out of there. Calculate. One variable stats on list L2. I just want what I'm interested in. This one. 209,518.07. 209,510, not 8, 0.0735. This problem should take a few minutes. 2 at the most. You're not going to have more than 4 subintervals, and I let you choose left, right, mid. It's up to you. I think we worked a lot on antiderivatives because we looked at indefinite integrals. But if you would like to choose, let's choose. We know the most general antiderivative, so let's look at antiderivatives that are unique. So, for example, I have the book here, and these are in 4.9. Okay, so let's look at 69. We are given a of t equals sine t minus cosine t. We are told s of 0 is 0, and s of pi is 6. They're asking us, so this is the antiderivatives. So they're asking us to find the distance function. We have to find the velocity, which function prime is sine, so that is negative cosine, minus which function prime is cosine, sine t plus a constant c. Both conditions given to us are for s. I don't have any condition for v, so I cannot determine c yet. So then s of v would be minus sine t plus cosine t plus ct plus d. When I differentiate this, I get this. When I differentiate this, I get this. When I differentiate this, I get this. When I differentiate this, I get 0. Now I have to use the two conditions. S of 0 is 0. 0 equals 0, 1, 0 plus d. So d equals negative 1. So for now, what is that? For now, I have s of t as negative sine t plus cosine t plus ct plus 1. Oh, I meant minus 1. Good. Now we have to use the second condition. The second condition states that s is 6 when t is pi. Sine pi is 0, cosine pi is negative 1, pi plus c times pi, or pi times c, minus 1. So I'm adding 2 to 6, so it's 8 equals c pi. So c equals 8 over pi. And this has to be replaced here. And this is it. So finally, s of t, negative sine t plus cosine t plus 8t over pi minus 1. Questions on this problem, please?
No.
Okay. Moving on to the last two. Displacement plus total distance. So this is the net change theorem. And that is in section
5.4.
yes. Now, if you have a function that you would like to work from, 5.4, please choose it and give it to us.
So I have a two-part question.
Yes.
So it's the acceleration function in meters per second squared. and the initial velocity are given for a particle moving along a line.
Good.
So it's a of t.
Yep. Hold on,
equals
hold on.